I'm Leah Hildebrandt Ruiz. I'm an associate professor at the University of Texas at Austin. And in our study, we are building a coupled emissions and dispersion model to evaluate community exposures to air pollutants and noise from unconventional oil and gas development. As part of this work, we are also taking some measurements to be able to evaluate the model and also to fill some needs in the model in terms of emissions and emission factors. Yeah, we are currently taking measurements in the Eagle Ford Shale with our mobile measurement platform and our stationary measurement platform. In this first measurement campaign, we are focusing on emissions from flares. So with our measurements, we are able to characterize the emission factors and as well as the combustion efficiency of the flares, which will then serve as an input to the emissions model. We're in the process of organizing an open house for community members in the Eagle Ford Shale. We're coordinating that with Professor Meredith Franklin's team because they're also doing work in the Eagle Ford Shale. And so for that open house, we'll be informing the community about our study, explaining to them how it can be useful to them. And we'll also take our mobile measurement platform so that they can see some of our instrumentation. One reason why it's very useful to have a model to predict community exposures is because these emissions are constantly changing. As the energy transition is happening, as rules are changing. One example right now that we're considering are the new EPA methane rules, which will not just impact methane emissions, but also impact the emission of pollutants that are of concern to human health. So one of the things that we are working on right now is to estimate VOC emissions associated with unconventional oil and gas development, and also how EPA's new methane rules are going to impact those VOC emissions. I might point out one interesting impact of why we need to treat emissions and dispersion of pollutants. So emissions is how much gets into the atmosphere, and dispersion is where is it going to travel. In this study here, what we looked at emissions of benzene from these 27 black dots, and these 4 different graphs are the concentrations of benzene that result in 4 different meteorological episodes. So this demonstrates the impact of meteorology, basically wind speed, wind direction, on the concentrations that people will be exposed to.